Hello, everyone. We are live and we are here for the result declaration ceremony of the preliminary level of Aryabhat Astronomy Quiz 2023-24. We have with us as chief guest Professor Shami Chatterjee. He's live from Cornell University, USA. Welcome, Professor Chatterjee. I will give a brief introduction about Professor Chatterjee uh, before we proceed with the result declaration. He completed his BTech from IIT Madras in 1996. Thereafter, he completed his PhD from Cornell University in year 2003. And his research focus has been on nanohertz gravitational waves, pulsar timing arrays, the radio transient sky, fast radio burst, neutron stars, the precision astrometry, neutron star proper motion, and parallaxes. So students who are waiting for an interaction session, they have an idea on what specific topics to ask from and get their queries resolved. So before the session and before the result declaration, I would like to request the Secretary of Aryabhat Foundation, Mr. Harshit Duggal, to give a brief introduction of the astronomy quiz which was conducted this year. Mr. Duggal, over to you.
Thank you, Divyam. Uh, uh, Good evening, Professor Chatterjee, uh, everybody on the call. Uh, so this year, we concluded the 28th year of the quiz. So we've been able to conduct it with grace and a lot of effort. There were challenging times during COVID, but we did not stop the activity, and we did it with the limited resources at that time that we had. We do not take any grants in terms of monetary grants from government or non-government organizations. So it is with the contributions of the volunteers and our well-wishers through which we conduct this two-tier quiz. So the quiz, uh, like a lot of us know, is a two-tier quiz. This is the preliminary level of the quiz, where we'll be selecting around 53 students who would then get trained uh, with some qualitative training over weekend camps for the next almost 3 months for their final examination, which will be a practical examination including viva voce and a, a project presentation somewhere in the month of December. This year, it's been an amazing journey for us. We have had more than 100 schools participating, almost 117 schools, and more than 8,000 students participating in the quiz. Um, Almost 60 schools out of these are remote, where the team had to physically go to conduct the quiz, and there was no direct mode of transport to reach also. So kudos to the team for conducting the quiz in remote areas of the country, and that has shown us results as well. This year, you will see going forward, a lot of the selection has happened not from the top cities of Madhya Pradesh, but actually from the hinterlands of the state. So the largest, the school having the highest number of students getting selected is actually almost 500 kilometers away from the city of Bhopal, which is the capital where the base of the organization is. So yeah, without further ado, there's a lot of things that have happened and are going to happen. So exciting times ahead. So yeah, Divyam, let's go ahead and you know show people what results are there.
Thank you, Mr. Duggal, for giving a brief introduction about the organization of how we have conducted this quiz so far. Now, I would request permission from Professor Chatterjee to go ahead and we press the button for declaration of the results for this year.
Please do so. Yes.
So here on screen, you will see the results. Around More than 8,000 students participated, and they're eagerly waiting for the results. This is the statistics. Around 5,000 boys, more than 3,000 girls participated. 117 number of schools were there. At the bottom of the screen, you can see uh, a chart in which highest number of participation we saw from a school, JNS Bhopal. Then we have other schools like Graphite School, Mandsaur from Varasivni, Neemach, Khor, Gwalior, Betul, Balaghat, Ashoknagar. So we have a lot of schools here. Next on screen, we will see now these are the names which we are waiting for the final selection. And here are the names: Meg Tatia, Garvit Agrawal, Arham Jain, Arush Mittal, Ayush Baghela, Anirudh Loya, Mohammad Akram Ansari, Yashpal, Athar Soni, Sarthak Yadav, Garvit Rathor, Arush Singh, Tanmay Bhoot, Aksh Nakul, Devraj Valecha, Ranak Chaurasia, Anay Parik, Avyan Korane, Sarvagya Kaushik, Mohammad Atif, जतन हिरानी, मोहम्मद मूसा, प्रिंस अश्वरे, आदिदेव गोयल, प्रियेश तिवारी, अभिषेक कोल, आर्यन सिंह, हिमांशु नामदेव, वेद मेश्राम, अनिमेश वर्मा, अंकित धाकड़, भास्कर राउत, सौंदर्या कोठारी, सम्यक कोठारी, अनंत अग्रवाल, सिद्धांत दास, कनिष्क मलू, आर्यन पटेल, सूफिया आरिफ, विवान पोद्दार, प्रभात जायसवाल, राजा चौरसिया, हार्दिक तुरकर, राजवीर राठौर, राजवीर गौर, नित्या सिंह, मोहम्मद फरजान, आर्यन कनौजिया, देवांश त्यागी, तेजस सरोटे, प्रीशा गोयल, Vedika Maurya, and Pratik Raghav. These are the 53 total students who have qualified for the second round of Aryabhat Astronomy quiz. So all these students will now be preparing and going through various practical stages. This is a summary of selections. We've got selections from these various schools. Total number, as secretary also mentioned, is the highest number of selection is from a school which is based in Mandsaur. Thereafter, selection we've got from Bhopal, Gwalior, Varasivni, and so on and so forth. Thank you, Shreyas, for the seamless presentation. And now I would like to request Professor Chatterjee for his words of inspiration for the students who have been selected in the second round. Professor Chatterjee.
Well, thank you very much. It's a great honor for me to be here. This is extremely impressive, and let me congratulate all of the organizers on this tremendous effort. I mean, this looks like it has been an astonishingly successful effort. And my special congratulations to all the students who have worked extremely hard, who have participated. 8,000 plus participants. That is amazing. And I just want to congratulate each and every one of you. Your participation is extremely impressive. And of course, only some of you are selected for the second round, but that's how it goes. For every participant, though, I want to say your interest in science is what is the key thing here. You'll have many opportunities in your life, and your engagement, your curiosity, your interest is what will carry you through. Like I have, in my life at least, I've found, there's lots of people who are smart, but hard work is what is the most important thing. It is more important than how smart you are. Smartness is common. Hard work, um, compassion, wisdom, these are the qualities that will be of great use to you throughout your life. So again, my congratulations to each and every one of you. I hope you go on to do great things, and I'm sure many of you will. Thank you.
Thank you, Professor Chatterjee, for these words of wisdom. Next, we have the Joint Secretary of the organization. He will give a brief vote of thanks before we move on to the interaction session. Mr. Alok Mandavkanya.
So thank you everyone for joining this session. I would first of all like to thank Chatterjee sir to grace us with his kind words. And I would like to especially thanks Amit Vishwas, who got in touch with Mr. Chatterjee so that he could be here. So special thanks to Mr. Amit. Then, as Harshit mentioned, this year's quiz reached new heights with participation of over 8,000 students. So, kudos to all the volunteers who worked hard for that. Then, I would also like to thank all the parents and teachers who are the support of all the students and who encouraged and enabled all the students to participate in this quiz. Finally, the actual students who did all the hard work of studying and participating in this quiz, and all the activities and all the future activities are actually for them only. So thank you to them as well. So I would like to conclude this ceremony with this vote of thanks. Thank you.
Thank you, Mr. Mandal.
And congratulations to all of you. This is extremely, extremely impressive organizing and extremely impressive participation by the students. Very nice.
Thank you once again, Professor Chatterjee. With this, the result declaration ceremony comes to an end. And now I would like to call all the students who are waiting in the background for the interaction session with Professor Chatterjee. I will be moderating this session. I will start taking names. I have a name of students who have questions and who are waiting for interactions. So first, I would like to bring on stage Meek Tatia, who's waiting from Bhopal. Meek, if you have a question, you can unmute yourself and ask it. Go ahead, Meek.
And I'm happy to answer questions on anything really that you might want to ask. I may not have answers for everything, but I'm happy to take a stab at it. If you want to ask me anything about science, anything about me, I'm happy to take the questions. Again, I don't know that I will be able to answer them, but please go ahead.
Meek, if you can hear me, you can unmute yourself and ask the question.
Professor, I wanted to ask you, what was the main research?
Okay, if I understood that right, you're asking what is my main research focus right now? I have to say there's two big things that I'm working on right now that are particularly interesting. And one of them is, I'll tell you about low frequency gravitational waves. So this is kind of this is something that we didn't know about until fairly recently, but everything that we see, all of the interactions, all of the astronomical information we get so far has been through forms of electromagnetic waves. So we see light, we see radio waves, we see optical light, we see infrared, ultraviolet, X-rays. These are all forms of light. And until recently, everything that we knew about the universe came through these different forms of light. But Einstein's theory of relativity says that there are these things called gravitational waves. And these gravitational waves come through when space itself is squeezed and stretched because of massive objects. So, for example, if you have two massive black holes that are orbiting each other, they will stretch and squeeze the space between them, and they'll cause these ripples in the fabric of space-time. And we only theoretically knew about this until fairly recently, when instruments like LIGO were used to detect these actual gravitational waves from binary black holes merging with each other. And since then, what I've been working on, we've been working on detecting the low frequency gravitational waves from the merger of extremely, extremely massive black holes. So these are black holes with masses of 1 billion times the mass of our sun. So 1 followed by 9 zeros, that many times more massive than the sun. And when two of those are orbiting each other, they're orbiting very, very slowly. So it takes years for them to orbit each other. But meanwhile, they stretch and squeeze the space between them very, very slowly. And so we've been observing these cosmic clocks for 15 years. And now we can see over the period of 15 years, we can see the space between us and these clocks stretch and squeeze slowly. So it is really patient work. It is really long-term work, but it is showing very, very interesting results now. So that is low frequency gravitational waves are something fairly exotic that we didn't think we could detect as recently as like 30 years ago, but now we have actually detected them. Thank you for your question.
Thank you, Professor Chaudhary. Next, we have Aryabhat Thackeray, Sarvagya Kaushik, Adidev Goyal. Please be ready with your questions. First, Nitya, if you are able to hear me, kindly unmute. Also switch on your video.
As we India is the most great and there is
Professor, I think there is some echo in the background. If you, we'll be able to hear better. Nitya, can you repeat now?
So there is a lot of pollution in India because of the big population India has. So and it also makes it difficult for us to get access to a good sky. Can you please advise us on some ways to deal with this problem so that students who are interested in practical astronomy can pursue their interest?
That is a big question, and it is well outside my pay grade. Yeah, this is a really, really difficult question. I mean, on the bigger picture, in terms of the sociology with what you're asking, I think that India has made great strides. Yes, our population is still increasing in India, but I think that especially with more education for women and more resources being devoted to improve the outcomes for children in society, I think that our population growth rate is at least slowing down, and we're on track to basically get to the point where we will have a stable population. But I think it's particularly important that we focus on educating women who otherwise might not have access to educational resources, because that seems to have shown over and over again that is one of the best things we can do for our population problem. In terms of the actual pollution, I think that we are going to be seeing more and more this rapid transformation as we move towards cleaner fuel sources. Part of the problem right now that we are facing as a society, all humans everywhere, is the challenge of global warming and the fact that we have been pumping in carbon dioxide from fossil fuels into our atmosphere. We are basically using the energy that's been stored up for billions of years, and we're just spending it all in a very, very rapid fashion. And the carbon dioxide accumulating is causing global warming. There is this effort to move very quickly towards much cleaner fuels, including solar fuels, solar energy, or tidal energy. And all of that as a side effect entirely will also reduce population. So the side effect alone is incredibly beneficial to all of us. And I think that as a result of the reduction in pollution, we will also, as a very small side effect of this very big thing, we will end up with better skies for astronomy as well. But yes, otherwise, this is a very difficult question that you're asking, and there's not an easy answer. There's not a short-term answer to that.
And next, we have Sarvagya Kaushik. Sarvagya, you can unmute and ask your question.
Yeah. Good evening, sir. Myself, Sarvagya. So, I have a very interesting question. Is there any chance that we can escape a black hole?
That is an interesting question. And as far as we know, right now, our understanding of black holes is limited. But if you were inside a black hole, there is no chance that you could escape. And that is, in fact, what defines a black hole. The tricky part is you wouldn't actually get to go inside a black hole in the first place either, because once you got close enough to a black hole, you would probably be ripped apart by the tidal forces, because one part of your body would be closer to the black hole than the other part of your body. and you would get stretched out, squeezed, and ripped apart before you even went into the black hole. So you wouldn't have to worry about getting out of the black hole because you'd already be ripped apart before you got in. But no, what defines a black hole is that you cannot escape it. So in that sense, you could definitely not escape a black hole. Lovely question.
Thank you, sir.
Next, we have Adidev Goyal. Adidev, if you are there, you can unmute. Otherwise, we have Aryan Singh who's ready. Aryan, you can unmute and ask a question.
Good evening, sir. Myself, Aryan Singh. And my question is that, as we all know that the space is expanding, so is the distance between two stars also increasing slowly?
Yeah, that's a really good question, and it's a source of confusion even for people in graduate school. So it's a very good question. But no, when we say that space is expanding or Hubble flow, this is something that happens on very large scales. So faraway galaxies are separating from each other. But within our galaxy, for example, everything is gravitationally bound and space is not expanding. Things are not separating from each other. In fact, our nearby neighbor galaxies are actually falling towards us. So Andromeda, our next nearest neighbor galaxy, is actually coming towards us. And in a few tens of millions of years, Andromeda, which is right now a faint fuzzy patch in the sky, will be this huge thing that will be filling our sky. But that's in a few tens of millions of years, so you'll have to wait a long time before you get to see that sight. It will be spectacular. But even on nearby galaxy scale, space is not stretching apart. So stars within our own galaxy certainly are not moving apart from each other due to Hubble expansion. Hubble expansion happens on very large scales, so between distant galaxies. Nearby smaller galaxies or within our galaxy, things are much more bound up by gravitational forces. So it's the gravity between stars or their motions which determine how they're moving with respect to each other. Great question.
Before I move on to the next question, I would request everyone who is there in this feed to open their videos if it is possible, so that I can know, I can see a lot of faces in the screen and I know they're able to understand what Professor Chatterjee is explaining. Next, I have uh, Adidev Goyal, Atharv Soni. Adidev, if you can hear me, you can unmute yourself and ask your question.
Yes, sir. Yes, sir.
Please go ahead.
So I hope it's evening where you are now, sir. So good evening, sir. So my question to you is that
You are audible, Adidev.
yes.
Please continue.
So my question right now is that with the amount of gear we have now, so with the amount of gear we have now and the research we can do you think there will be a discovery which will change the way we think about this? We think about space and everything.
I'm sorry, could you repeat that? Will there be a discovery that changes the way we think about
Yes, sir.
the way we
Think
think of?
about the universe and the world as a whole.
Ah, okay. I'll try to answer that. I mean, I think that is. I mean, I would say yes, because I feel like even as recently as, let's say, 50 years ago, we did not have any idea, for example, that we could possibly detect something like gravitational waves, right? But now we have detected gravitational waves. We have a whole new window on the universe. It is a whole different way of looking at the universe that we didn't have before. You might have heard recently, a few years ago, we made the first image of a black hole. And that was using radio telescopes that spanned the entire world, all working together, so that you basically were creating a telescope the size of the whole Earth. And with that, we now have images of black holes. And that was not something that we believed was possible. Until very recently, our textbooks used to say that we have one sun and 9 planets, and that's all the planets we knew. Today, we know several thousand planets that are orbiting stars that are not around our sun, that are orbiting other stars. The discovery of these exoplanets, until 50 years ago, people would have said, no, they're too far away and too small for us to ever be able to detect. And now, not only have we detected these planets orbiting other stars, we're actually getting spectral information from them. So the quest now is to find out what their atmospheres are made of, and then possibly, maybe if we're very, very lucky, see if there's evidence for life on other planets, right? So I feel like we're astronomy right now, driven by technology, driven by advances in computation, in instrumentation. We're in this phase where we're making rapid strides on all of these fronts. And yeah, it is changing the way we look at ourselves. I mean, our place in the universe, when we started, there was just life on Earth. Then we understood that, okay, Earth is one of these 9 planets orbiting the sun. And there's other planets, and we talked about, is there life on Mars? Is there life on Venus possibly? And we know that there is not going to be life on Venus. There's the possibility that there was very, very long ago, many millions of years ago, there might have been life on Mars, even though today certainly there's not life on Mars. And our stage has expanded. We now think that, well, we now know of planets around other stars. We know of planets that are like the Earth, in around stars orbiting at a comfortable enough distance that they might have liquid water even on them. Might those have life? So yeah, there's lots of questions, and they're changing the way we look at our place in the universe.
Thank you, sir.
Right. Next, we have Athar Soni, Aryan Patel. Right. Athar is here. Athar, if you can unmute
Okay.
and open your
Good evening,
video.
sir. My name is Atharv Soni. And my question is, why does the particles of sun during the solar winds and solar storms travel the huge distance? Is there any external force applied?
The solar wind. So it's not just during a solar eclipse, during a total solar eclipse, we can see the solar corona. We can see the particles streaming off the sun. But they're streaming off all the time, regardless of whether there's an eclipse or not. And that's just they're just being ejected from the surface of the sun with very high speeds. So they're being ejected with high enough speeds that the immense gravitational pull of the sun is not sufficient to hold them back. And that's all it is. They're traveling, they're streaming freely out from the sun. They're passing through us, they're passing around us. The solar wind is just, yeah, it's just a question of they're being ejected with very, very high speeds from the sun itself. Yeah, it's until very recently we did not understand how the sun worked, actually, because our predictions for what we should be seeing, given the nuclear reactions that powered the sun, they did not seem to be observed on observatories on Earth. And there's a whole lovely story with neutrinos from the sun and the discovery that, well, it's possible that neutrinos have a tiny, tiny mass, and that allows neutrinos to change from one type of neutrino to a different type of neutrino. And that explains why the kinds of neutrinos we thought we would be seeing, we don't seem to see from the sun. There is just a very interesting detective story there as well.
Thank you.
And so
Next,
my
we
next,
have. Yes, Athar.
my next question is,
Okay.
so why does the age of sunspots is only for 11 years?
That is a complicated and messy question, unfortunately. It's a great question. We know that there is a solar cycle that seems to be roughly 11 years, during which the number of sunspots seems to rise and fall. And this has to do with hydrodynamics. And it is a very complicated topic that we can't explain, because we're talking about not just hydrodynamics, which is a very complicated topic, but hydrodynamics in the presence of this nuclear furnace, which is the sun. So yeah, I don't think we have an answer for that yet. It would be, what drives the solar cycle is a great question, and it's not something we understand very well. Maybe it's
Uh,
something that you can work on someday.
so next we have Aryan. After Aryan, we'll have Sufia Arif. Be ready with your questions. Aryan, you can unmute yourself, open your video, and ask the question.
Good evening, sir. Sir, I have a question that what is the reason for the expanding of the universe?
That, um, yeah, that is an unanswerable question. It's a difficult question to even contemplate. As far as we understand today, the universe was born in what we call this hot Big Bang, where 13.5 billion years ago, the universe, all of the substance in the universe was compressed to this compact, hot, incredibly dense, incredibly high temperature point. And then it started to expand. And as a result of this expansion, all of the structure that we see in the universe comes as a result of this beginning Big Bang expansion. And that's from where all of the elements are synthesized, galaxies form, eventually stars form, planets form. We show up on one planet and we ask, oh, why is the universe this way? And there's no way to answer that, because if the universe was not expanding like this, we can make models for universes where the universe does not expand. In those models, we don't end up with formation of galaxies and stars and planets and people, right? And so we don't know what happens in those universes. But in order for us to be here today to ask this question, why is the universe appearing to be expanding? The universe had to be expanding. If you see what I'm saying, it's a circular thing, right? If the universe wasn't this way, we wouldn't be here to ask, why is the universe this way? So it's this peculiar situation, and this is what is known as the anthropic principle in science. It's basically that we as observers, our presence requires a particular chain of circumstances to have happened, and then we can't really ask why that chain of circumstances, because without that chain of circumstances, we wouldn't be here to ask about it. Maybe some other form of intelligence would be, but we are not that form of intelligence. Right? So we can ask, why is the universe not steady state? If the universe was steady state, we wouldn't be here. Right? So I feel like this is a deeply unsatisfactory answer. But unfortunately, unless we could run this experiment with many different universes, doing many different things, there isn't a better answer to give you. It is a deeply unsatisfactory answer, I acknowledge that. But I I suggest you run many different universes, and then we can have a better answer. It's a great question.
Thank you, sir.
Thank you, Aryan Patel. Next, we have Sufia Arif. Sufia, you can unmute yourself and ask the question. And next, we will have Bhaskar Rao and Tanmay Booth. Sufia, go ahead.
Sir, I had a question. What would be some practical pieces of advice that you would give to students who want to pursue astronomy in India?
Right. That's a very good question. Unfortunately, I can only give you general advice, not very particular advice, because I don't have enough experience with the Indian system right now. But my number one piece of advice for students who are still in school is to definitely focus on your math, right? Having a good handle on mathematics in your coursework is something that has cascading effects through all of the rest of it. I mean, I feel like the details of science are easy to pick up if you understand the underlying machinery of the math of it. So focusing on math. And the other thing is to be able to focus on your writing skills, because you can be very good at understanding something, but unless you are able to explain it to someone else or express it for someone else, that's not very useful. And no one is going to give you credit for knowing something in your head if you couldn't express it, right? So they're very, very basic skills. I mean, we start off in elementary school teaching maths and writing, but it turns out those are the really important things that really, really matter right through your career. And so my advice is be good at math, be good at writing, and then the rest of it, I feel like you can pick up as you need. You can pick up science, you can pick up the other details as you go along. But focusing on the fundamentals, I think, is good advice.
Next, we have Bhaskar Raut. Bhaskar, you can open your video, unmute yourself, and go ahead with the question. Bhaskar, am I audible? Tanmay, you can also be ready in the background. Bhaskar, if you can unmute yourself and ask the question. Yes, go ahead. Issue the audio of Bhaskar. Tanmay, you can unmute yourself and ask the question. We'll come back to Bhaskar in a while.
Good evening, Professor. Myself Tanmay. I wanted to ask that what are your thoughts about our latest solar mission Aditya L1 and what changes can it bring to our solar astronomy?
I don't know specifics about solar missions, unfortunately. I don't work on the sun. It's a very interesting object to work on. It's extremely important, but I don't know enough about specifics of the missions, unfortunately. But I do know that we, like I said in answering a previous question, there's lots of details about the sun that we don't yet understand. The details of the energy production, and it's really, really important because the sun allows us to exist. It directly or indirectly powers everything about the earth. So it's very important. I don't know enough details to give you a better answer.
Sir, I have another question. What do you think about dark matter?
Yes, okay. Dark matter is something that I'm troubled by, let's say, because all of the scientific evidence says it must exist, right? It is very clear that there is something whose gravitational effects we are detecting, but which we are not detecting through any other electromagnetic evidence. So I am confident that it does exist, but I'm really unhappy about our state of understanding of it because we don't really understand what it is made of. And there are many theories about what it could be made of, all the way from maybe they're teeny tiny black holes to there's some kind of exotic particle that doesn't interact with any other particle. I don't know the answer to what it is made of. It is a topic that is of extreme interest to a lot of astrophysicists, trying to figure out what it is made of. And yeah, we don't know. It's kind of amazing because it turns out that most of the constituents of the universe are dark matter and dark energy. And normal matter, which is all that we are sensitive to, is a tiny fraction of the universe. So in that sense, the bulk of the universe is still waiting to be discovered. And so that's also incredibly exciting.
Thank you, sir. That was all.
Thank you. Next, we have Garvit. If you have a question, you can unmute yourself and ask the question.
Good evening, Professor. I am Garvit Rathore. Sir, I have a question that if we have a nebula with the gases as the same is the same components as our atmosphere have, like it has a 78% nitrogen, 21% oxygen. If any nebula has the same constituents of gases in it, can we live? Can we normally breathe if we will stay there without any space too?
Right. That is a good question. If you had a nebula with the exact composition of the Earth's atmosphere, and it was really an exact match, then I could imagine that you could breathe it and survive. It would be extremely unlikely to have a nebula with the exact composition of the Earth's atmosphere, because the Earth's atmosphere composition um, is affected not just by the history of the Earth, but also by the presence of plants, which are taking in on net carbon dioxide and pumping in oxygen. Oxygen is extremely reactive, right? So free oxygen in the atmosphere doesn't last long. I mean, one of the reasons why, for example, the surface of Mars is red is because any free oxygen in the atmosphere of Mars has reacted with iron minerals to form effectively the equivalent of rust, right? So oxygen would go away very, very quickly because it's a highly reactive element. The only reason there's free oxygen in the atmosphere of the Earth is because on net, plants are putting more oxygen into the atmosphere than we are consuming, right? And so that's why there's free oxygen. So I think it's incredibly unlikely that you'd have a nebula with the exact same composition as the Earth's atmosphere, because the free oxygen in that nebula would react very, very quickly with other things and it would go away. But if you did find a nebula with the exact composition of the Earth's atmosphere, yeah, I think you could breathe it. It would be weird because there wouldn't be gravity, you'd be kind of free floating. But yeah, maybe. Wouldn't last long though. It would be a very, very lucky coincidence.
And now we are
Sir,
coming towards. Yeah, you have a follow-up question? Go ahead, Garvit.
yes, yeah. Sir, if we had something there, we know that the universe started with Big Bang. So we can we there is a point where the Big Bang started, and where this universe started, the point where it is located.
Yes. And that's an interesting question, and the answer is also very interesting. The Big Bang started everywhere. So this is one of those things that you have to think about really to make sense. But if every place was compact as a point, then every place is where the Big Bang started after the expansion starts. And you can see evidence for this. For example, if you want to look at echoes of the Big Bang, we can study something called the cosmic microwave background. And the cosmic microwave background is basically the echoes left over of the initial radiation of the Big Bang. So it's literally, we are seeing the leftover radiation of the Big Bang just stretched out to very long wavelengths because of the expansion of the universe. And which direction do we see the cosmic microwave background in? Every direction, because the Big Bang happened everywhere. So no matter which direction you look in the sky, you can see the cosmic microwave background radiation. And so that proves this idea that the Big Bang happened everywhere. In fact, it is one of the pillars in our understanding of the Big Bang and the fact that the expansion led to the formation of all of it. And it was at no particular place, it was at every place. Because remember, the Big Bang is not happening in space at a point, it is creating space. So it's a weird thing to understand, but yes, it happened everywhere.
So we come towards the end. If Bhaskar is there, Bhaskar, you can unmute and we'll take it as a last question.
Yes. Sir, can you hear
Yeah.
me?
Yeah, you are
Sir,
audible, Bhaskar.
so my question is that, sir, as you have, sir, as LIGO has detected gravitational waves, sir, do those gravitational waves, when coming to Earth, don't they encounter stars which create their own gravitational waves? So the information would the information get interrupted or disturbed by the stars' gravitational own waves when coming to Earth? So this is my doubt.
That's a really interesting question too. But the stars, well, first of all, stars are not creating their own gravitational waves per se, because they are very, compared to black holes, they are not very compact and not very massive, right? So they do produce gravity, they do stretch the space around them, because, for example, the reason planets can orbit a star is that the star is distorting the gravitational potential around it. But it is distorting the gravitational potential, but not enough to interrupt the passage of gravitational waves. So you can imagine, for example, what would be a good analogy? Let's say you rolled a marble on the floor, and then there was a little dip in the floor. The marble could roll down the dip and back up the dip and keep going, right? So the gravitational waves would take the gravitational potential of the star and they would go right through it, because there are much shorter timescale oscillation, and the gravitational potential of the star is a much more long-term thing. I mentioned to you briefly nanograv, where we have detected gravitational waves from supermassive binary black holes. And so these are much lower frequency gravitational waves. They have periods of many years. But there you can see they would not see the interruption of things like stars. What's very interesting is that there's a gap in between these two bands. So LIGO is seeing gravitational waves which oscillate thousands of times per second. Nanograv, or the pulsar timing experiments, are seeing gravitational waves that oscillate once or twice a year. So this gap between thousands of times a second and a few times a year, there's a huge gap in between. And in that gap, there's a lot of interesting gravitational wave science to be done. There are missions. So to detect them, you need to fly spacecraft in space. And so there's something called the LISA mission, which involves flying these spacecraft in space thousands of kilometers apart, and then measuring the distance between them to the precision of the size of an atom. And then those spacecraft would be stretched and squeezed by the passage of gravitational waves. And those gravitational waves would be in the band in between. And it turns out that the LISA mission is going to detect lots of interesting things if and when we can make it work and get it to fly. It is going to detect gravitational waves from white dwarfs and inspiraling stars, and also from regular stars that are interacting with each other. So there's going to be a lot of interesting things in that particular band of gravitational waves that we don't have the instruments to detect yet. But there's fun stuff to be seen.
Sir, can I ask one last question? I have really a doubt about. So, if according to Einstein, if the speed of light is not relative, then why do the light of stars, which are more than beyond 13.5 light years away from Earth, not reach us right now? If it is not really dependent on time.
But you can't, the speed of light is a constant, that is right. But because of the Big Bang, because we believe the universe began at the Big Bang, there is nothing that is further away that is within our detectable horizon, if that makes any sense. The horizon that we can see to, we can look, as we look further away, we're looking also backwards in time. So within our galaxy, that means that the light of stars within our galaxy, we are seeing them as they were tens of years ago, hundreds of years ago, thousands of years ago. So within our galaxy, the stars that we're seeing, some of them are, we're seeing them as they were thousands of years ago. For other galaxies, we're seeing as they were millions of years ago, and even in some cases, billions of years ago. But then beyond that, there's not enough time in the universe for us to see anything from that far back. And so that's why we have a horizon at 13.5 billion years, before which there is nothing to see. And so that is the furthest we can see.
Thank you, sir.
It's a bit of a mind-stretching question.
Thank you, Professor Chatterjee, for oscillating between different topics and bringing your vast level of knowledge to the level which students are, and giving your words of wisdom. I think that was immense, was very helpful for these students. Before asking you for some concluding remarks, I would request Mr. Amit Vishwas, who is also here and has joined us, to give brief views on how he has seen this interaction and how his journey with Aryabhat has been.
Well, thanks for putting me on the spot, Divyam. Well, first of all, I'd really, really like to thank Shami for agreeing to be here. Shami, you've been an inspiration to me ever since I've known you, and I couldn't have thought of a better person to come here today and talk to these kids. And thank you so much for taking the time. This must have been really, really exciting. I mean, it was for me just to hear you answer all these questions, and I bet these kids are gonna remember this for a while. Now that you've put me on the spot, I actually would like to share something. Recently, I was looking up some really old pictures, let's just say that, and I found a few things. Let me bring up a picture. It's a, as I said, a really old picture. Let me see if I can share my screen.
Shreyas, is possible? Can you bring that picture on the screen?
All right, can you see my screen?
Yes, it is there.
All right. So Shami, this just goes on to tell you, two of the people on this call, me and Alok, are in this picture. Both of us standing in the Nainital Observatory. This is probably early 2000s. Probably 2000. Do you remember, Azza?
Yeah, yeah. It was the summer of year 2000. So just the new
Okay, all
millennium
right.
had started. Yeah.
And this is us talking to Professor Ramsagar about Jupiter, I believe.
Yeah, yeah.
And
The image hasn't showed up yet. I think it's
oh,
still on the.
it hasn't? Oops. Maybe I need to
Yeah.
share screen again. Um, there you go.
Still loading.
Yeah. Anyway, I just want to say that the whole experience of participating in the quiz was an incredibly educational one. Really helped me, you know, guide my energies into what I liked and what I wanted to do. Uh, one quick bit about like I did my undergrad in computer science, and one of the things that I enjoyed learning while I was learning astronomy was all these other tools, as Shami was saying. It's incredibly important how you write, and learning all these tools. I think I learned how to run Flash, and we made our presentation in Flash instead of PowerPoint. So it really has been an education, really, coming through this quiz and getting that exposure early on in life. You know, all the kids that you were speaking to today are probably between class 6 and 9 still. Is that right, Harshit? Yeah,
Yeah, now we select from 6 to 9th.
6 to 9. Okay, yeah. So yeah, this has been very nice, and I'm really, really glad to see that this is still going on. 23, at least 23 years later, 24 years later. Is there a silver jubilee coming up of Aryabhat?
It's already over.
28 done. This is
Okay,
the
wow.
28th year.
So I guess congratulations, and I'm really happy that I can still remain associated with you guys and help out here and there every once in a while. And again, thank you so much, Shami, and thank you everyone else for participating today.
Thank you, Amit Bhaiya. And then lastly, I would come to Professor Chatterjee for his concluding remarks on the interaction and the whole session.
Yeah, thank you again. Really, thank you for having me. This has been really fun for me as well. I really enjoy the diversity of questions that people come up with. It's always fun to see what's on people's minds, what strikes their fancy, and what the range and width of questions is. It is really, really impressive. And my congratulations to all the participants. I think that it is really, really great that you are all participating and taking an interest in science and taking an interest in the bigger picture. I think this serves you well throughout your lives. And so, congratulations to each and every one of you. And I hope that you will take this opportunity to keep building on your curiosity and working hard to find more answers to more questions. Eventually, getting to the point where you can ask really good questions about the universe that no one else can answer. And that's just things to find out. I do think that we are in what is a golden age of astronomy right now, especially for astronomy. Like I said, with the improvements in technology, the improvements in computational power, we're in this stage where we are finding out things and learning things about the universe and our place in it that we didn't even think was possible too long ago. So it's a great time for astronomy. It's a great time for science in general. We are also living in extremely difficult times, as you know very well. Our circumstances in the world, with climate, with pollution, with everything else, we have challenging circumstances ahead of us, and we do need bright, talented young students who can address some of these challenges for society as a whole, for science, for technology, for all of it. So I hope that some of you will be stepping into these roles in the years to come. My special congratulations to the organizers for this fantastic event. It is really great. You are doing some very, very impressive work in finding students from all over the country and finding talent that would otherwise not be found. My special congratulations to you. And really, thank you for having me. It has been absolutely my privilege to be here. Thank you.
Thank you, Professor Chatterjee. With this, we come to the end of this interaction session. This video was live on YouTube as well, and a lot of students from different schools were joining through YouTube links which were circulated. That's all. Thank you, everyone. Thank you all.